Hey, welcome. Every single time you save a file, you're interacting with this hidden system that organizes all your data. Today, we're going to pull back the curtain on a key part of that system that you probably never even see, the inode. So, I want you to think about this for a second. You see a name on your screen, right? Something like report.txt and the little icon. But is that really the file? Or is that just a friendly label for something way more fundamental hiding just beneath the surface? Let's find out. Okay, let's dive right in. It turns out every single object on your file system, every file, every directory, everything, has a kind of hidden identity. It's like a unique serial number that the operating system uses to keep track of everything. And that identity is the inode. So you've got this split. On one side, you have the file name, report.txt. That's for us humans. It's a convenient label we can read and change whenever we want. But on the other side, for the computer, the real deal is the inode number. The name you see is just a pointer, a signpost pointing to the inode, which holds all the information that truly matters. And here we have the official definition from the source material. So what's the big takeaway here? It's that the inode stores everything about the file. Who can open it, how big it is, where to find it, literally everything, except for that friendly name we see. The name is separate. Okay, to really nail this down, let's use an analogy. Imagine your entire hard drive is one giant library. All your files are the books on the shelves. And the inode? Well, that's the old school card catalog entry for each and every book. The file name is just the little label on the shelf telling you which card to look up. All right, so if we're sticking with this library idea and the inode is the card catalog entry, what's actually written on that card? Let's take a look inside and see what makes up the anatomy of an inode. What kind of metadata are we actually talking about here? Well, it's all the crucial nitty-gritty details that your operating system absolutely needs to manage the file correctly. And this table here, it lines up perfectly with our library card idea. The I mode tells you who's allowed to read the book, the permissions. The user and group IDs, that's kind of like the author and the publisher. The timestamps tell you when the book was last checked out or published. And the size is just the number of pages. See? It all maps. Okay, but I really want you to zoom in on this one field. I-links count. When you first create a file, this number starts at 1. It's basically keeping track of how many different file names are pointing to this one inode. Trust me, this little number is going to be a huge deal in just a couple of minutes. Okay, all that metadata is great, but here's the absolute most important job of the inode. It tells the system where to find the actual file content. It holds pointers or addresses to the specific blocks on your hard drive where the data is physically stored. It's the IL5 shelf 3 part of our library card. And this is where file systems get really clever. Check this out. For super tiny files, things like symbolic links, the system doesn't even bother using a separate data block. It just crams the data right into the pointer space inside the inode. It's like writing a very short poem directly on the library card instead of needing a whole book for it. Pretty smart, huh? Okay, so we've got the pieces, the file name, the inode, the data. Now let's see how they all work together when you do something you do 1,000 times a day, just opening a file. How do we get from the name to the data? But first, we need to clear up a really common misconception. We call them folders, but to the file system, a directory is actually just a special kind of file. And the contents of that file are super simple. It's just a list, a table that maps the human-friendly file names to their inode numbers. That's it. So, picture this. You double-click report.txt. What happens in that split second? First, the system looks inside the directory file for the name report.txt. Second, it grabs the inode number right next to it. Third, it uses that number to go find and load the correct inode, our card catalog entry. And finally, it reads the pointers in that inode to go find the actual data blocks and show you what's inside. It's that simple, and it happens in a flash. All right, I know this might seem a little deep in the weeds, but why does any of this actually matter? Well, because this whole design, the separation between the name and the data, has some really powerful consequences you see every day, even if you don't realize it. For starters, it makes something called a hard link possible. Since the file name is just a pointer, you can have lots of different names, even in different directories, all pointing to the exact same inode. And get this, it's not a copy. It is the exact same file, just with 2 different labels pointing to it. And that brings us to maybe the biggest aha moment of all when it comes to file systems. When you drag a file to the trash and hit empty, what's actually happening? Is that data actually gone for good? Nope, not even close. All the system does is remove that entry from the directory file. It erases the link between the name and the inode number. Then it finds that inode and just subtracts 1 from its link count. The actual data, the ones and zeros on your disk, are totally untouched. So here's the golden rule. The file system doesn't consider that data deleted until that ilinks count finally hits 0. Only then are those data blocks marked as free space that can be overwritten. And that right there is exactly how data recovery software works. It's just looking for data from inodes whose blocks haven't been overwritten yet. Oh, and fun fact, there is no inode 0. It's a special, reserved number. Oh, and there's another awesome side effect to all this. Have you ever wondered how renaming a massive 10 gigabyte video file is just instant? Or moving it to another folder on the same drive? It's because you're not moving 10 gigabytes of data. You're just editing a tiny text entry in a directory file. The inon and all that data stay put. So if you remember just one thing from all of this, make it this. The name is just a label. The inode is the reality. It's the file's true identity, the real record that the system cares about. So from now on, when you hit save, just take a second to think about what's really happening. You aren't just creating a name. You're creating a new entry in this massive invisible catalog on your drive, a new inode with its own unique identity. And understanding that, well, that's understanding a core piece of how your computer actually works. Thanks for tuning in.